Okay, in this side here, we want to prove it true for all permissible values, which means you don't have to state the restrictions. So I'm going to go to my formula sheet here and I'm going to try working on the left-hand side first. So I've got 2 times, and then I'm going to times that by sine x plus y. So sine x plus y is going to be sine x cos y plus cos x sine y. And that will be multiplied by cos of x plus y. So cos of x plus y is going to be cos x cos y minus sine x sine y. So let's apply the distributive property to be able to do this. So I'll distribute the 2 in. So I have 2 sine x cos y plus 2 cos x sine y, and then that will be multiplied by cos x cos y minus sine x sine y. Okay, let's apply the distributive property. So I'm going to multiply first term with first term. So I have 2 times sine x cos x, and I see that I have a cos squared y. Then I'm going to distribute the first term with the last term. So I'm going to go minus 2 times cos x and sine y. Okay, so I'm going to go sine y, cos x, y, sorry. And then I've got 2 sine squareds. So sine squared x. Okay, and the next one I'm distributing here and here. So I have plus 2. I notice there's cos x and cos x. So I'll write down the sine y cos y, and then the cos squared x. And then the last one that I multiply here together, I'm going to go, I have the sine y's in common this time, so I'm going to go 2 minus 2 times sine x cos x, and then sine y times sine y is sine squared y. Okay, looking at these, I am going to, let's see, I'm going to look for things that are in common that I can kind of group together to factors. So here's where my eyes go. I have a 2 sine x here and a 2 sine x here. And then I have a 2 sine y here and a 2 sine y here. So I'm going to rearrange my terms. So I'm going to take all the ones with the sine x together, and then I'm going to factor it out. So I'll just rearrange it first. So I've got 2 sine x cos y squared minus 2 sine x cos x sine squared y. And then I'll rearrange it so the sine y's are together. So minus 2 sine y cos y sine squared x, and then plus 2 sine y cos squared x. Okay, so I rearranged those so that they are together. Now I know that 2 sine x cos x, that's my double sine angle identity. So that's just sine of 2x times cos squared y minus, again, 2 sine x cos x, that's the double angle identity. So that's sine of 2x sine squared y minus, again, 2 sine y cos y, that's the double angle identity. So that's sine of 2y, and that's multiplied by sine squared x plus double angle identity here, sine of 2y cos squared x. Okay, now what I'm going to do is I'm going to look at this and factor out a sine 2x. So I get cos squared y minus sine squared y. And then minus, over here, I'm going to factor out a sine 2y. So minus sine 2y, take that out. So then I'm left with sine squared x minus sine 2y cos squared divided by negative 2 sine y is cos squared x. Okay, so cos squared minus sine squared, that is one of the double angle identities for cosine. So if I look at cos 2a, that's cos squared minus sine squared. So this is really sine of 2x times, this is the cos double angle identity, which is cosine of 2y. Now, this one here, sine squared minus cos squared, is a double angle identity, but it's supposed to be cos minus sine, so I need to factor out a negative. So I'm going to factor out a negative from here, and with that negative there, it becomes a positive. So sine 2y, but I factored out a negative, so I can switch those guys around. So it's going to be cos squared minus sine squared. Okay, so this is really going to be sine of 2x times, I actually don't need my brackets. I can just write it like this. Sine of 2x cos 2y plus sine 2y, and then cos squared minus sine squared is just the cos double angle identity cos 2x. Now let's compare that to the other side. Sine 2x times cos 2y plus sine 2y times cos 2x. So it's the same on both sides. So sine 2x cos 2y plus sine 2y cos 2x. So what I've done now is I have shown that the left side of this is equal to the right side of that. And since LS equals RS, this identity is proved.